Hello everyone and welcome to this lecture on prompt engineering. This will be a lecture specifically dedicated to some of the advanced techniques in prompt engineering. In particular, we will be looking at four techniques. First is called as in-context learning. So let me switch to a different color here, which is green maybe. Yeah, so the first technique is in-context learning. The second technique which we are going to look at is chain prompting. The third technique which we are going to look at is chain of thought prompting. And the fourth technique which we are going to look at in today's lecture is tree of thought prompting. We will also understand why these different types of techniques are developed, what are the advantages, disadvantages of each technique, and when you should be using each of these techniques. First, let's get started with in-context learning. Now, to explain what in-context learning means, I would actually like to go to the paper which was published in 2020. This was the paper on GPT-3, language models are few short learners. When this paper was released, even the authors had mentioned that what really helps in getting good responses from large language models like GPT-3 is we provide certain examples. So the main goal of in-context learning is instead of just describing the task and asking ChatGPT, why not we show ChatGPT or the large language model how the task is to be done? So the main idea is that we can provide the large language models with examples of exactly the thing which we want to achieve. This simple change can lead to a tremendous improvement in the quality of the output responses which are given by ChatGPT or the large language model. This is called as in-context learning because we provide the model with correct examples which we want. There are in an essence three types of in-context learning. The first is called zero-shot prompting. Why is it called zero-shot? Because we prompt without giving any examples. This is what we learned in the previous lecture. This is basic prompt engineering where we just ask a text to ChatGPT. So, and give an instruction. So zero shot prompting could be classify the text into neutral, negative or positive. And then the text is I think the food was okay. And that's it. And then we ask ChatGPT to give us the sentiment of this text. Here you can see that we have not provided any example. One shot prompting is where we provide ChatGPT with a single example. So classify the text into neutral, negative or positive can be the instruction. And then along with this we provide an example. For if the text is I think the food was alright, the sentiment is neutral. This is one example of an output which we expect. And then we give the actual sentence I think the food was okay. And then we ask ChatGPT to provide the sentiment of this sentence. You see how it's different from zero shot prompting? In zero shot prompting, we did not provide any example. Whereas in one shot prompting, we do provide example. An extension of one shot prompting is a technique which is called as few shot prompting. In few shot prompting, we provide multiple examples, not just one example. So here you can see the instructions remains the same. Classify the text into neutral, negative or positive. But here you can see we have given three examples, 1, 2 and 3. In the first example, we give a text, I think the food was alright, and we tell that the sentiment is neutral. Then we give a text saying that I think the food was great, and we say that the sentiment for this is positive. And then we say that I think the food was horrible, and the sentiment is negative. These are the prompts which we are giving to ChatGPT, and then we give it a final text such as I think the food was okay, and we ask ChatGPT what is the sentiment of this. You would not believe this, but this simple change, this simple addition in the prompt makes a huge difference in the kind of responses we get. So think about when your parents were teaching you, right? When parents were teaching you something, they told you examples of what is right and what is wrong, and then you were able to understand it better. That's the similar case with ChatGPT or large language models. So when the research paper for GPT-3 was released in 2020, I believe, the authors in fact had a detailed section on the importance of zero shot, one shot, and few shot prompting. So here you can see zero shot, one shot, and few shot. And in few shot, as what we saw, the authors have mentioned that in addition to the task description, the model sees a few examples of the task, and that makes a huge difference. So here they have given a translation example. In zero shot, we just say translate English to French and give the prompt cheese. In one shot, we tell ChatGPT to translate English to French, but we give an example of how sea otter is translated. And in few shot, we tell ChatGPT to translate English to French, but we give multiple examples, such as sea otter translates to this, peppermint translates to this, and plush giraffe translates to this. And then we ask ChatGPT, okay, what does cheese translate to? So that's an example of few shot learning. Alright, I hope all of you understood in context learning, the three types of in context learning, which are zero shot, one shot, and few shot. Now what we are going to do is we are going to look at a simple demonstration in Google Colab. So I'll open the Google Colab interface right now. And yeah, we are going to look at an example of in context learning, right? So before we come to the actual example, first you need to do a few things to run the code. This code has been taken from Hands-on Large Language Model book by J. Alamar, and I'll share the Google repository link in the information section, but you have to install these packages first, and then we are actually loading a pre-trained model here. So in the Google Colab notebook, we are not interacting with GPT 3.5 or GPT 4. Instead, we are interacting with Microsoft Phi 3 mini model, which we have loaded on our desktop from Hugging Face. So if you go to this model itself, you'll see that it's a relatively small model, 3.8 billion parameters. That's why this model I prefer for demonstration purposes, but because it's small enough and it still works pretty well. So in the first code cell, we have loaded the model from Hugging Face itself, and we have loaded the tokenizer also, and we have created a pipeline. What this pipeline says is that we are going to use the model and we intend to use it for the purposes of text generation. And we are also saying that the maximum number of new tokens which are generated when we generate new text is going to be 500. Alright, so you'll need to run this code cell, and then you can move to the section which is titled as in context learning. Now we are going to take a very interesting example here. Our goal is that we are going to use a made up word which does not exist in the dictionary, and we are going to generate a sentence out of it. We are going to teach ChatGPT, or not ChatGPT, this large language model Microsoft Phi 3, how to use a made up word and generate a sentence out of it. Now, in the spirit of in context learning, we are going to try one shot prompting, which means we are going to give one example of how such a made up word can be used. So role is a user initially, which means what we are providing. And here I am saying that a gigamuru is a type of Japanese musical instrument. This word gigamuru does not exist. And an example of a sentence that uses the word gigamuru is. So I could have directly typed this into the LLM and asked it to generate the sentence. But first I want to show it what kind of sentence is possible. So I actually give the content and I say the role assistant, which is the LLM, and I say that if the gigamuru is the made up word, then a good use of this is I have a gigamuru that my uncle gave me as a gift. I love to play it at home. So since gigamuru is a musical instrument, I am showing the LLM how it can construct the answer using this made up word. So remember, I said the role here as assistant because I am telling the LLM what I want its response to be like. And then finally I give the sentence, I give the main prompt which I want the LLM to answer. And then I say that to skrig something is to swing a sword at it. An example of a sentence that uses the word skrig is. And then I am expecting the LLM to generate some sort of a response. Now I could have asked this directly, but instead what I have done is that I have given two sentences before which teach the LLM how to use a made up word like gigamuru. So now the made up word in the actual prompt which I am giving is skrig, right? Such a word does not exist in the dictionary. But now the LLM knows what is the kind of answer I'm looking for, because I used Gigamuru and I showed it how I used Gigamuru, although that was also a made up word. So now I have given it an example, that's why it's called one shot prompting, and I want to see what the LLM does based on this new example. So first I print out the chat template. So here I can see the user. So I provided the Gigamuru prompt and then I gave the response what I want the response to look like. And then finally I gave the prompt which I'm giving to the LLM. And then I will pass this prompt through the pipeline which I just showed you above over here. This pipeline which we created using the Microsoft Fire 3 model. So I pass this prompt through the pipeline and then you will see the answer. During the medieval reenactment, the knight skillfully screeched the wooden target. So to screech something is to swing a sword at it. So that's correct. The knight skillfully swung a sword at the wooden target. That's pretty awesome, right? This clearly shows that we have used a made up word and we have taught the LLM how to use it in a sentence through a one shot prompt approach. So the final sentence which the LLM has generated is that during the medieval reenactment, the knight skillfully screeched the wooden target, impressing the onlookers with his prowess. Which means the knight swung a sword at the wooden target and impressed the audience. So here we have trained the large language model to generate a sentence with a made up word. And we gave the example using another made up word called Gigamuru, and then finally we asked the question regarding how it can use the made up word Skreeg, and then the response which we got is what I showed you right now, this response, which is pretty awesome. So we just generated a sentence with a made up word, and this is the power of in context learning. If you provide some examples to the large language model, it generally understands what you expect it to do and then it responds in a much better manner following your expectations. This is a very simple advice which you should keep in mind when you are interacting with chat gpt or any other large language model. Always provide some examples along with the prompt. One shot prompting and few shot prompting really helps. That's the first takeaway from today's lecture. So we have covered in context learning. I'm going to put a tick mark here. And now we come to the next method, which is called as chain prompting. So chain prompting essentially means just breaking up the problem into smaller pieces. I'll tell you what it means. If we have complex prompts, right? If we want to ask ChatGPT to do many things, instead of asking everything in one prompt, it's advisable to give it a prompt, get the response, then ask the second prompt based on the response, then ask the third prompt, etc. So instead of breaking the problem with just a single prompt, we can also do it in between prompts, right? So we can first ask one prompt, get the response, then ask the second prompt, etc. So we take the output from one prompt and then we use it as an input for the next. That's why it's called as chain, right? So imagine I have given prompt number 1, then I get the output number 1, right? Now this output is used as the input for the second prompt number 2. Then using the second prompt I get the second output, which is output number 2. Then the output of this is used as the input for prompt number 3. You see a chain is forming here, a chain of multiple prompts and outputs which are linked to each other. That's why this is called as chain prompting. And I'm just now going to tell you or show you a very practical example of chain prompting, which is a new feature integrated in Google Colab itself. So let's say I want to write a code about statistics. I want to make a plot about a normal distribution. Just so that all of you are aware, a normal distribution is something like this, which has a mean of 0 and a standard deviation equal to 1, right? I want to write a code in Google Colab which makes a normal distribution like this. So let me start. I'll click on the generate feature over here and I will type write a code to generate a normal distribution, and I'll press enter, right? So this is the output, and if I run this code, you will see that the normal distribution will be generated and I'll get a plot soon. So what I've done until now is the first part of the chain, which is the first prompt which I asked. It generate a normal distribution, and the output I've got, which is a normal distribution which has been generated, as you can see over here. Now I want to give a second prompt to this, which means that what I want to do is I want to have sliders to control the mean and standard deviation. Now you see what I'm doing here. This is the prompt. This is the prompt number 2, which will take the output as its input, the output of the previous prompt, and then it will operate on top of that. So I'm going to write this second prompt and I'm going to press enter. So it will take the code which it has already generated. It won't do anything new, but it will just add interactive sliders. So I'll run this now, and okay, here you see the sliders have been added. So I can move these sliders and you will see that the normal distribution changes, right? Now what I want to do after this point is that I want to, or I should click on generate. I want to export, or I want to change the color of this plot to green. Now when I write this, this is the prompt number 3, right, which is operated on its previous output, which is output number 2. You see how I am chaining different prompts together here. This is the perfect example of chain prompting. So you can run this over here right now, and you will see that the color of this line has been changed to green. Awesome, right? This is an example of chain prompting where multiple prompts and their outputs are chained to each other. By the way, this is also a very cool use case of generative AI with Google Colab. So I hope with this example you have understood chain prompting. I want to show you chain prompting through one more example, which is a more commercial example. So let's say we want to use a large language model to create a product name, slogan, and sales pitch based on a number of product features. So let's say you are the founder of a startup and you have made a product, and you want a large language model to create a product name, slogan, and also sales pitch based on the features of the product. So already the example is such that the prompt which you need for this is complex, right? So instead of having just one huge prompt, why don't you break it down into parts? So what we are going to do here is that we are first going to generate the product name and the product slogan, and then based on this we are going to generate the sales pitch. So see, we are dividing it into two parts. The output of the first prompt is the input to the next prompt. The output of the second prompt is the input to the third prompt, etc. So we are going to do this in stages. So chaining prompts like this allows the large language model to spend more time on each individual question instead of tackling the whole problem. So what happens when you give all of these things at once? ChatGPT cannot provide, or the LLM cannot give equal attention to all of the queries. So it does provide a coherent output, but the attention is split, divided between the different things you want it to do. That's why chaining is better, right? Instead of multitasking, you focus on one task, finish it, go to the next task. You chain the different prompts together. Alright, so I'm going to show this to you now in the Google Colab interface, which we have been working on. Until now, we saw in context learning. Now I'm going to show you chain prompting with the example which we just saw right now, related to creating the product name, slogan, and the sales pitch, right? Alright, so first thing what I'm going to do is I'm just going to create a name and a slogan. That's it. I'm not going to create the sales pitch for now. That I will do in the second prompt. So what I do is I say the role as a user, which means what we are giving as a prompt. And the prompt which we are giving is create a name and slogan for a chatbot that leverages large language models. And then I'm going to pass this prompt through the pipe and I'm going to generate the output. So if you print this, you will get the name. So the name which the LLM has generated is Chat Sage, which means a wise person. And slogan is unleashing the power of artificial intelligence to enhance your conversations. So let's say you're a founder of a startup which is building a chatbot to leverage LLMs. You have got the name and the slogan for your marketing campaign, let's say. And now you want to generate the sales pitch. So the prompt which you give after this will utilize the product description which you have obtained earlier. So the second prompt which we are going to give is generate a very short sales pitch for the following product. And here we are going to give the output which has been generated previously. This is the chaining. The output of the previous prompt is now the input to the next prompt over here. And then we are going to create the sales pitch out of this. So generate a very short sales pitch for the following product, and the product is the product description which we have obtained in the previous part. When you run this, you will get the pitch which is introducing Chat Sage, the revolutionary AI powered tool designed to elevate your conversations to new heights. With our cutting edge technology, we unleash the power of artificial intelligence to enhance your interactions, making every conversation more engaging, insightful, and meaningful. Experience the future of communication with Chat Sage today. So you see what this has done is now there are two prompts. So ChatGPT operates in two stages. So in the second prompt, it can just focus on making the sales pitch. In the first prompt, it can just focus on making the name and the slogan. Dividing the output of ChatGPT into manageable modules like this makes a big difference in getting better outputs, in getting coherent outputs. Because now what we are doing with chain prompting is that ChatGPT or the LLM can spend more time on each individual question instead of tackling the whole problem. So please keep this technique in mind. It's also a very practical technique which you can start implementing already, along with the in context learning which we saw before. So what are the use cases of chain prompting, and what are the different areas where chain prompting can actually be used? Let's see. So first is response validation, right? Let's say you get a response, then you add another prompt saying that is my response correct? Are there any errors, or can you verify it? So that's an example of chain prompting. Second is parallel prompts, which means that if you want to create multiple recipes, let's say person 1 is making the recipe number 1, person 2 is making the recipe number 2, and person 3 is making a recipe number 3. You give 3 separate parallel prompts to get these 3 recipes, and then you combine the outputs of these prompts together to generate the shopping list. So this is also an example of chain prompting, right? Because the output of these prompts serves as an input to this prompt over here, which is going to generate the shopping list for you. And the final example is writing stories. This is also a great example because first you are going to write, let's say, just the names of the characters. After the names of the characters are written, you are going to write the first chapter of the story. Based on the first chapter of the story, you are going to write the main, let's say, climax of the story. So you won't give the prompt for writing the book in one go. You will break down the prompts into different smaller prompts, and you will chain them together. So writing stories is also a great example of using chain prompting. So there are 3 examples which we saw right now: response validation, parallel prompting for, let's say, generating recipes and then merging them together to create your shopping list, and finally writing stories. So now we have finished the second part of this lecture, which is chain prompting. So I'm just going to put a tick mark over here. Until this point in the lecture, we have finished 2 modules. We have finished in context learning, which is very practical, where you can give some examples uh, to your prompt itself, and that really increases the quality of the output produced. And then the second is chain prompting, where you can break up the problems into different parts, so that instead of analyzing the whole prompt at once, chat gpt or the llm can focus on one prompt at a time, one smaller prompt at a time. So these are very practical examples which we saw. Now what we are going to do is that we are going to look at reasoning. which means that until now, what people discovered is that ChatGPT can give responses, it can summarize text, it can translate into different languages, it can generate code. All that is fine. But is it really good for reasoning? Can ChatGPT really think like how humans think? And that led to a whole new uh, types or techniques of prompting, which we are going to see next. And those are called prompts for reasoning. All right. So the main thing which people discovered is that can we somehow introduce some techniques, or can we somehow make the prompting a bit better so that we can train the large language models like ChatGPT to reason. So when we say artificial intelligence, reasoning is a very core component of human intelligence, right? And so, if we really want an AI to be as good as humans in responding to our queries, we need to make sure that the LLM can reason. The LLM has reasoning capabilities. And this is still an open question, and lot of researchers are working on this. But the main idea of giving prompts for reasoning is that we work together with large language models through prompt engineering so that we can mimic the reasoning processes, and that will also improve the LLM output. So sometimes the LLM does not output responses which are very good because maybe it's not thinking. What if through intelligent prompting we can teach the LLM to think before responding? We can teach the LLM to be a bit slow, take its time instead of having quick responses. Maybe we should train the LLM to think before, right? So if you go to ChatGPT and if you have upgraded to the paid version, they have this oven preview. And if you see over here, uh, if you scroll here, you will see that oven preview and oven mini uses advanced reasoning. So OpenAI as a company is slowly moving towards large language models which can reason well, right? So let me give some question that Roger has 5 tennis balls. So he buys 2 more packs of tennis balls. Each pack has 3 balls. How many balls does Roger have now? And if you press enter here, you will see that ChatGPT is thinking. It thought for 1 second and then it responded, and then it got to the answer of 11. Because we have 5 tennis balls and then he buys 2 packs of 3. So 5 plus 2 into 3. So that will be 11 balls. But if you just go to, if I copy paste this and if I go to GPT-4o, right? And if I type this, here you will not see that it's thinking over here. It directly gives the answer. That is the difference between GPT-4o and O1 Preview or O1 Mini. Let me show that to you once more. If you go, if I change this to O1 Preview, right, and if I type this, just observe here, it comes that the LLM is thinking. See this thinking and gathering insights. So it's a bit slow in giving responses. It doesn't directly give out the responses like GPT 3.5 and GPT 4 did. You will see that it thinks for 7 seconds. That's what is meant by reasoning. Before blurting out the answer very quickly, we can train or teach the LLMs to think before answering. And that brings us to different techniques which can enable or which can help LLMs like ChatGPT do a better job at reasoning. So the kind of, so people like to compare it to the way humans think, right? And there is this book called Thinking Fast and Slow. This book by Daniel Kahneman, in which this is one of the best books I have read. And in this book, the author argues that the human mind essentially consists of two systems, System 1 and System 2. System 1 is fast, instinctive, and emotional, and System 2 is slower, more deliberative, and more logical. So, the parallel which people are drawing is that before we thought of reasoning, ChatGPT really behaved like System 1, where it gave fast, quick answers. But can we also train it to behave more like System 2, where it thinks, it plans, it reasons, and then it provides the answer. That's the main idea. So here I have the schematic of system 1 and system 2. You will see that system 1 is fast, subconscious, automatic. So unconscious, fast, automatic, and system 2 is slow, conscious, effortful. Whenever we want to plan something or make complex decisions, it's system 2 which is engaged. So system 2 is generally more reliable than system 1, but it takes a bit more time. Although I'm not making the claim that what ChatGPT does in O1 Preview and O1 Mini is exactly like System 2, it's a good way to think about where the world is moving, right? Because ChatGPT earlier, if you see GPT 4.0, it did not come like its thinking and its reasoning. But O1 Preview and O1 Mini, you will see that they used advanced reasoning. So somehow we are moving from system 1 to system 2. It's a good intuitive way to think about why GPT or why OpenAI is introducing new models. Okay, so now we are going to look at different techniques for reasoning and different ways in which we can prompt ChatGPT or LLM so that they can reason or think better. The first technique which we are going to see is called as chain of thought prompting, which is think before answering. So the aim of chain of thought prompting is to have the large language model like ChatGPT think first rather than answering the question directly without reasoning. This method was first proposed in this paper which I am sharing on the screen right now. Chain of thought prompting elicits reasoning in large language models. This paper showed that how this chain of thought prompting significantly improves the ability of large language models to perform complex reasoning. So if you Google search this paper right now, you will see that it has around 10,000 citations in 2 years. It's a highly influential paper. So I'm going to describe the technique which has been outlined in the paper. This technique is clearly explained with this one diagram. So let's say first I show you without chain of thought prompting and then I show you the same example with chain of thought. So without chain of thought prompting, what we do is that let's say the question is Roger has 5 tennis balls. He buys 2 more cans of tennis balls and each can has 3 tennis balls. How many tennis balls does Roger have now? And let's say we do it with one shot prompting, which means that we first teach ChatGPT that the answer to this is 11. And then we give a new question. The new question which we ask is that the cafeteria has 23 apples. If they use 20 to make lunch and bought 6 more, how many apples do they have? So the correct answer to this is that the cafeteria had 23, right? And they used 20. So 23 minus 20, and if you add 6, then that leads to 9. But the answer which the LLM has provided here is 27, which is wrong. This is an example of the case where if we don't use chain of thought prompting, we get to a wrong answer because maybe the LLM or chat GPT is not reasoning well. So the main concept behind chain of thought prompting is that instead of giving just this answer is 11, we also tell how we came to that answer. So we prompt with a reasoning example. We don't just provide the answer, we provide how we got to that answer. So Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 balls. How many tennis balls does Roger have now? That's the question. Instead of just saying that the answer is 11, we also teach the LLM or chat GPT our reasoning process or our thinking process. So we say that Roger started with 5 balls, 2 cans of 3 tennis balls each is 6. So the answer is 5 plus 6, which is 11. And that's why the final answer is 11. So we teach or we include the reasoning in the prompt itself. Or we teach the LLM or chat GPT how to reason within the prompt itself. And then we ask the new question. The cafeteria has 23 apples. If they use 20 to make lunch and bought 6 more, how many do they have? Now you see the answer. The answer given by ChatGPT is it also includes its reasoning process in the answer because we have taught it. So the answer is the cafeteria had 23 apples originally. They used 20 to make lunch. So they had 23 minus 20, which is 3. And they have bought 6 more apples. So they have now 3 plus 6 equal to 9. That's the correct answer. So chain of thought prompting uses reasoning examples to persuade the generative model or chat GPT or any other LLM to use reasoning in its answer. So the main essence of chain of thought prompting is that we show the model the reasoning it should do. And these reasoning processes are referred to as thoughts. That's why it's called chain of thoughts. We can provide multiple such thoughts aggregated together. That's why it's called chain. So chain of thoughts prompting, which means that we provide our thought process within the prompt itself. And that's why this is called COT. So you'll see articles referred to as COT. The COT refers to chain of thought prompting. If you are solving mathematical problems, or if you are solving logical or reasoning related problems, or if you are a teacher or an educator, you must have seen that LLM sometimes produces wrong answers. They cannot reason very well. This one technique, which is chain of thought prompting, can really help you to teach the LLMs arrive at the correct answer. But you have to explain your reasoning or your thought process in the prompt itself. Alright. So now what we are going to do is that we are going to see this in code. So I'm going to take you to the Google Colab interface right now. And the topic here is reasoning with generative models. So the prompt so let's say we do not use chain of thought prompting. That is the left hand side case over here, right? The one shot prompt without the thinking process. So if we do not use it, we just give the prompt, the Roger and tennis balls prompt, and then we just say that the answer is 11, and then we ask the new question about the cafeteria. The cafeteria had 25 apples. If they use 20 to make lunch and bought 6 more, how many apples do they have? Here actually what we see is that it has generated the correct answer even without including the chain of thought. And that might be probably because we are using the Microsoft we are using the Microsoft Phi 3 instruct model, right? And this model is already trained on a large instruction data set, or pre-trained on a fine-tuned on the large instruction data set. So some of these reasoning protocols might be in that data set itself. But now here I am showing you how you can modify this prompt. So this is a standard prompt. The way to modify it with the chain of thought is that in the assistant, so here you can see the user has given the query, the Roger tennis ball example. Now in the assistant, what you write is that you show the reasoning. Instead of just writing the answer is 11, you show why it is 11. Roger started with 5 and then 2 cans of 3 is 6. So 5 plus 6 is 11. That's why the answer is 11. And then we ask the cafeteria question. If the cafeteria had 25 apples, if they use 20 and bought 6 more, how many apples do they have? And here you can see the cafeteria started with 25 apples. They used 20 to make lunch. So they had 25 minus 20 equal to 5 apples left. After buying 6 more apples, they now have 5 plus 6, which is 11 apples. That's why the answer is 11. So since we taught the large language model the reasoning, it has responded with a detailed reasoning procedure in the output. So this is an example which shows using chain of thought prompting how you can do better at reasoning and at mathematical and logical problems. Now there is one more way to make chain of thought prompting very easy. So instead of writing the entire reasoning, what you can actually do is that you can just write one single step, like let's think step by step. So you start with the prompt without the example, but when you give the example, the cafeteria had 23 apples. If they use 20 and bought 6 more, how many do they have? You don't just ask chat GPT to give the answer. What you say is you ask it, let's think step by step. So then you prime the reasoning. The advantage with which this has is that you don't have to give any example. So this is called a zero shot chain of thought. Zero shot chain of thought is, here you see we directly ask the cafeteria question. We don't even give the Roger tennis ball example over here. So this is not a one shot case. The previous example which we saw was a one shot prompt because we had given the Roger tennis ball example, but this is a zero shot prompt. But still we will see that it does very well because we have primed the reasoning. In the prompt we have asked, let's think step by step. So here we don't have to provide detailed reasoning in the prompt. So it's easier for the user. If you yourself are sometimes confused about the reasoning, what you can do is, don't worry, when you make the prompt, just ask in the prompt, let's think step by step. So in the code, the way this works out is that you can just give the zero shot chain of thought prompt. The cafeteria has 25 apples. If they use 20 to make lunch and bought 6 more, how many do they have? Let's think step by step. And you print out the output. So then you will see that because you have mentioned let's think step by step, the LLM now starts thinking step by step, right? So it writes down all the steps in its thinking process and it actually gets to the correct answer. That is the advantage of making small changes in the prompt. I can even show you this in Chat GPT right now. So let's go to GPT 4o, which is not trained for reasoning, and let's write this prompt. Let's think step by step. And let me press enter. So here you will see that because I have mentioned let's think step by step, it starts answering step 1, step 2, and step 3. Instead, what I'll now do is that I'll just type in, go to new chat and type in how many apples do they have. So here you see it does not answer step by step. It does not say step 1, step 2, step 3. Directly answers 11 apples left. So making that one small change in the prompt that answer this step by step makes a big difference. So within chain of thought, we actually saw two things. We saw the one shot chain of thought prompt, and we also saw the zero shot chain of prompt. The zero shot chain of prompt is easier for the user, where you have to just mention let's think step by step. Okay, all right. So now we have covered three things in today's lecture. We started with the in context learning, then we went to chain prompting, and now we have finished covering chain of thought prompting. Now what we are going to do is that we are ready to move to the last section of today's lecture, and that is the tree of thought prompting. Before that, one thing which I would like to mention is that although the prompt let's think step by step can improve the output, you should not be constrained by this. You should always be creative. You can always try new things like take a deep breath and think step by step. Let's work through this problem step by step. Both of these approaches can work. So no need to directly follow what I am telling here. You can even be creative and change the prompt as you see fit. Another thing which I want to mention is that to ensure consistency, you can even try the same prompt multiple number of times, and this sometimes helps. So in this case, let's say you have the Roger example, and if you say let's think step by step, maybe sometimes ChatGPT makes a mistake because it's a zero shot prompting, and although you have said let's think step by step, you have not given any example. So if it makes mistake once, it's fine. You can run it 5 to 6 times, and then you can take the answer which has come maximum number of times. So here it's the majority vote. So if you ask this prompt and run it 3 times, if it's wrong once, it's fine. But if it's correct 2 of the times, then you should pick the majority vote, which is the answer is 11. So this is also very important. Don't just, sometimes it's a variable, it's a probabilistic process, right? You sometimes when you give a prompt, it may be wrong. So don't conclude that chat GPT is giving me the wrong answer. Try to have the same prompt 5 to 6 times and see the result which you are getting, and then take the result which has come majority of the times. All right, now we come to the last section of today's lecture, and that is tree of thought prompting. So before coming to the implementation, what I'm going to do is first show this research paper on tree of thoughts. So if you actually Google this research paper right now, you will see that it also has around 1650 citations. It was published in Neurips, and this was just released last year. So if you explore this paper further, you will see that what the authors have written is that even if you consider chain of thought prompting, it's not really a good representation of system 2, which is slow, deliberate, and conscious mode of thinking. Because in the chain of thought prompting, there is no planning really, right? What we do is we first plan, we plan various things. But in chain of thought, if you see, let me go to the chain of thought example. In the chain of thought, what we are doing is that okay, we are teaching the reasoning process, but we do not know that how ChatGPT is registering the reasoning process. We are hoping that it looks at our reasoning and then it mimics that reasoning, right? But we don't know what's happening under the hood. We don't know how it's solving this complex problem. So in tree of thought, we kind of address this gap by ensuring that we also explore the intermediate steps before we come to the final answer. In chain of thought, we directly come to the final answer, although we teach ChatGPT how to reason, but still it can be thought of like system one because we immediately, in a quick manner, come to the final answer. Tree of thought prompting is a bit different. It explores intermediate steps in a lot more detail. It plans before it reaches the final answer, and that's what the authors have also mentioned in their paper. That tree of thought is the conscious attempt to take the prompting closer to the system 2, which is the slow, deliberate mode of thinking. Uh, so they wanted to include some sort of a planning process in the prompting, and that's the inspiration for the tree of thought. The simplest way to think about the tree of thought is this particular schematic, where let's say a question is asked, right? What happens in the tree of thought is that, just like let's say if you're collaborating with 50 people on a research project or in a coding project, all of them have ideas, right? Similarly, when a question is posed, there will be multiple thoughts. Here there are two thoughts, right? Then thoughts are rated. If this thought has a high rating, then the answers of this thought are processed. Then if this has a high rating, then the answers of this thought are processed. Then finally, the thoughts with the highest rating are considered, and that is the final answer. So you see here we go through multiple rounds of reasoning processes and we consider various ideas and we rate these ideas. All of this happens internally. So when we say we rate the ideas, the large language model itself is rating the ideas. So at each step, the model is prompted to explore different solutions and it then votes for the best solution and continues to the next step. So let me show an example of this which is mentioned in the paper itself. So they actually show examples of mathematics and English, but I'm going to show the math example which is very interesting. So it's the game of 24. The goal here is that we will give four numbers and somehow you have to use these four numbers and use arithmetic operations of addition, subtraction, multiplication and division to obtain 24. So if I give numbers 4, 9, 10, 13, how will you ask ChatGPT to perform this task? We know that the final answer maybe is 10 minus 4 into 13 minus 9, which is 6 into 4 equal to 24. But if ChatGPT is just given this input, how will it know what operations to place where so that it comes to the final answer? So already you can see that this is a difficult problem which will require a lot of planning. It will require a lot of trial and error. So normal basic prompting will not work. So in tree of thought, what is done is that a tree is created. First you have the input of numbers which is 4, 9, 10 and 13. In the first branch or in the first level of the tree, the LLM or ChatGPT explores different options. So here you can see that first it starts with 10 and 4. So it subtracts 10 minus 4 equal to 6. Then which numbers are remaining? 4 and 10 are utilized. So the numbers which are remaining are 9, 13 and this 6. So the numbers remaining are 6, 9 and 13. Then one more idea is maybe you start with 4 plus 9 equal to 13. And if 4 and 9 are exhausted, the numbers remaining are 10, 13 and this answer 13. So left are 10, 13 and 13. So let's say a bunch of thoughts are generated or the bunch of ideas are generated in the first step. Then what is done is that these are evaluated. So let's say if 10, 13 and 13 are left, it is impossible to construct to reach 24 right with what is left, because if you have 10, 13 and 13, if you add them it's 36. If you subtract 13 minus 10 into 13, that's 39. There is no way to obtain 24 with these big numbers. So then this is shown in red because this thought is rejected. Because if you are left with 10, 13 and 13, you can never reach 24. So this thought is rejected. But this thought is accepted. So we proceed further. Then similarly in the next step, multiple other thoughts are generated. Then again voting is done and some thought is selected. So if 10 and 4 are utilized in the first step, then 13 minus 9 are utilized. So what is remaining is 6 and 4. And so in the final step of the tree, you multiply 4 with 6, which is equal to 24. So you see there is a proposed prompts and then all of these prompts are evaluated and then we go to the next step. That's why it's called a tree, because multiple thoughts are evaluated in one branch. Then we go to the next branch or the next level and we keep on going until we finally get to the correct answer. So here you see we are kind of peeking inside the thought process of chat GPT, and we are seeing how it is really working. That way it's different than chain of thought. In chain of thought we directly get to the answer, although we teach the reasoning process, we do not know how it's thinking. So here it's more like it's planning, right? It's planning how to get to the correct answer. So it's slow, it's deliberate, and that's why it's more related to the system 2 type of thinking which we had explored over here. uh, Let me scroll up a bit. Yes, the system 2 type of thinking which we had explored over here. That's the difference between the tree of thought prompting and the chain of thought prompting. So the advantage of tree of thought is that it's tremendously helpful when we need to consider multiple paths, like when writing a story also or coming up with creative ideas. So the second example which these authors give in the paper is that of creative writing. So here's that example. The input is write a coherent passage based on 4 short paragraphs, and there are some rules. The end of each paragraph must be, some things are there in the prompt. Then what is done is that in the first step multiple approaches are proposed. So this is plan 1 which is proposed, plan 2, plan 3, 4, 5 are proposed, and then the LLM or chat GPT itself votes on each plan. So here you can see that plan 2 has received 3 out of 5 votes, which is the highest, so it's marked in green. So this plan is selected, then we move next. And here you can also see why this plan is selected. Choice 1 seems to lack a clear connection between the paragraphs, so choice 1 is rejected. But you can see here choice 2 offers an interesting perspective by using the required end sentences, and that's why the best choice is choice 2. So after this is selected, then we go to the next step, which is actually generating the paragraphs. So that's why you can see here it's called plans, because it's planning how to accomplish this task. So that's why tree of thought prompting is tremendously helpful when we need to consider multiple paths, such as in the mathematical problem which I showed you and the creative writing problem which I showed you. The disadvantage, of course, is that it slows down the application because it is investigating several different branches, right? And since we are mimicking system 2 type of thinking, it's slow. Here also in the mathematical example which you saw, it's exploring all of these branches. So naturally it would take a large time to finish this computation. Alright, so the simple trick to speed up the tree of thought computation is that we ask the model to mimic the tree of thought behavior by emulating a conversation between multiple experts. So these experts will question each other till they reach a consensus. So remember imagine 6 experts sitting in a room. Imagine you are given this same problem, 6 experts are sitting. Each expert proposes something which is similar to the level in the tree. Then the ideas of some experts are selected, some are rejected, then we go to the next round after all the experts agree in one round. So similar to branches in the tree, if you have multiple experts, that actually makes the tree of thought uh, process a bit quicker. So we will ask the model to mimic the tree of thought behavior by emulating a conversation between multiple experts. And these experts will question each other till they reach a consensus. This is very important. So I'll just show this to you in code right now. So, tree of thought exploring intermediate steps. So, imagine 3 different experts are answering this question. All experts will write down one step of their thinking, then share it with the group. Then all experts will go on to the next step. If any expert realizes they are wrong at any point, they will leave. And the question is the same as what we had seen earlier. The cafeteria has 25 apples. If they use 20 to make lunch and bought 6 more, how many apples do they have? Make sure to discuss the results. So if you give this prompt and then if you print out the answer to this prompt, you will see that expert 1, expert 2 and expert 3. So expert 1 only stayed for one step where he or she said that you start with an initial number of apples. Then expert 2 was there for 2 steps where expert 2 suggested that you start with an initial number of apples and then subtract 20. And then in step 2, expert 2 suggested that you add the number of apples bought, which is 6. Then expert 3 also suggested the same thing. You start with the initial number of apples, which is 20. Then you subtract the number of apples used for lunch, which is, you start with 25, you subtract 20 and then you add 6. And then the result is that all 3 experts arrived at the same answer. The cafeteria has 11 apples left. 25 minus 20 plus 6, which is equal to 13. So here you see the steps here mimic the levels in the tree which we just saw. I took a simple example here, but now if you take the same mathematical example which I showed you, the goal is to combine the numbers 4, 9, 10 and 13 to get exactly 24. And if we give the same prompt, imagine three different experts are working together, the experts have a really hard time. So you'll see expert 1, expert 2, expert 3. So expert 1 says that let's start by trying to combine all the numbers with addition and multiplication. They get to an answer which is not 24. Expert 2 says that we can try division as well. Expert 3 says that we can use parentheses as well. Then all of them move to the next round. Then all of them move to the third round. And you will see that still we have not converged to the correct answer. They're trying various different things. But here you will need a lot more rounds than the simple example which I showed you earlier. Maybe at the 10th round or the 11th round, the experts will converge to an answer. That's why tree of thought takes a bit more time than chain of thought, but it's also very useful for solving complex problems. As you can see in the paper, they have some results which shows that the tree of thought prompting achieves a lot of success on mathematical problems like game of 24, then comprehensive problems in English literature where we have to generate stories from multiple different angles or multiple different ideas or which satisfy multiple constraints, etc. So these are the advantages and disadvantages of tree of thought prompting. Alright, so now we have got to the end of this lecture where we have now finished tree of thought prompting also. So I'll put a tick mark here. Just to summarize, we covered four things in today's lecture. We started with in context learning, where we saw the importance of providing examples. So we learnt about few shot, zero shot, few shot and one shot. Then we learnt about chain prompting, how breaking up the problem into different parts. So we saw this chain and we saw Google Colab notebook. You remember where we plotted a normal distribution and then we chained it with multiple prompts. So having a chain allows the LLM to spend more time on each individual question instead of tackling the whole problem. Then we saw, so these two are very practical. You can start implementing them even right now, chaining the prompt and adding examples. Then we saw two other examples which mimic or which are better if you want ChatGPT to reason on complex mathematical problems, logical problems, or problems which involve a lot of planning. So first is chain of thought prompting, in which we tell the LLM or ChatGPT how to reason. We show the reasoning process and then we ask it a new question. Here we also saw a zero shot version of chain of thought, where we directly give the instruction and then we just give the prompt, let's think step by step. And finally, we saw an extension of chain of thought, which is the tree of thought, which goes a bit deeper than chain of thought, because here we investigate what happens in the reasoning process itself. So we saw a mathematical example for a game of 24 and how we can solve it in different levels or different depths of the tree, how we can have different plans, then select one plan, then go next, then select the best idea in that branch or that level, then move next, and slowly we can converge to the final answer, not just in a mathematical example but in a English example as well for generating essays. We also saw that the train of or the tree of thought is a bit more complex and that might take more time than the chain of thought algorithm or the chain of thought prompting technique. So that's it. We've covered four concepts: in context learning, chaining prompts, chain of thought, and tree of thought. I hope you learnt a lot through this lecture. In the next lecture, we are going to cover controlling the model output from ChatGPT, or large language models. So we'll see different validation techniques, why safety is so important, and that will be the end of the prompt engineering lecture series. Thanks everyone. I hope you are liking this approach of writing on a whiteboard plus learning through code. I'll see you in the next lecture.